video, we are going to attempt MCQs questions related to periodic trends, and we are going to attempt the MCQs, and it is for AP chemistry. Before going into further details, first I just want to discuss electron affinity. So what we mean by electron affinity? Electron affinity is the energy change when 1 mole of electron are added to 1 mole of neutral atom in gaseous state. Remember, the atom must need to be in gaseous state, and it is going to forming 1 mole of gaseous ion. If we look at the electron affinity for sodium, it is going to be represented as sodium in gaseous state is going to gain electron, and it is going to be converted into gaseous ion. Okay, so now, and we can also take the example of chlorine in gaseous state. It is going to gain 1 electron and is going to be converted into chloride ion in gaseous state. So this is a way to represent electron affinity. So first of all, we need to see one thing here, that first electron affinity, then that is when you are adding first electron, when first electron has been added to a gaseous atom, then what happens, like for example, we have chlorine and it has 7 electrons in its outermost shell. So what happens when an electron has been added into it? Then there is a force of attraction that is developed with the atom and the electron. This is a nucleus in the center, and when this electron has been added into it, then a force of attraction that is developed between the nucleus and this electron. And one thing, when a force of attraction is developed, then energy change is, when a force of attraction is developed, then energy change is exothermic. So we have seen that first ionization energy first electron affinity is always going to be exothermic. Now you can see this chloride here that has become an anion after gaining an electron, and now when an anion is gaining electron, then what happens, between them there is a force of repulsion that exists between them, and in order to overcome this force of repulsion, we need to provide it energy. Okay, in order to overcome the force of repulsion between anion and upcoming electron, we need to provide energy, and this make second electron affinity to be endothermic. So if we look at the trend of electron affinity in period, then we are going to see that electron affinity is dependent on the nuclear charge. So greater the nuclear charge, you are going to see greater is the force of attraction that is created between the nucleus and the upcoming electron. So what happens, electron affinity that increases across the period because of increase in nuclear charge, and the other factor is going to be atomic size. So what happened that as atomic radius decrease because of increase in nuclear charge, atomic radius decrease because of increase in nuclear charge, so electron affinity also increase, because decreasing atomic radius means that there is more force of attraction of nucleus and the valence electron. So we have analyzed this thing that electron affinity is inversely proportional to atomic radius. So if we are going to look at the trend in group, then what happens because of increase in shielding electrons, and because of increase in atomic radius. So what is happening because of them? The force of attraction of nucleus and upcoming electron decreases. And when the force of attraction decrease, then what happens? It results in decrease in electron affinity as we go down the group. So electron affinity decreases as we go down the group because of increase in shielding electrons and increase in atomic radius. But although there is also increase in nuclear charge in groups, but these two factors in fact minimize this factor. So because of this factor, in fact, electron affinity, we are going to see electron affinity decrease across the group because of increase in shielding, okay, and that is because of increased shielding and because of increase in nuclear charge and that is because of these two factors. The other factor which is because of increase in shielding and because of increase in atomic radius. And although the nuclear charge is also increased, but these two factors minimize that effect. So now in the first question of this MCQs part, they are saying which element has the atomic radius. So if you are going to see these elements and they belong from period 3, all of them belongs from period 3, and we know one thing, that what happens as we move across the period, first of all, nuclear charge is increasing and atomic radius is decreasing. So, increase in nuclear charge, and the other is going to be that atomic radius decrease because of increase in nuclear charge. Atomic radius decreases. Why it decrease? Because of increase in nuclear charge, the nucleus is having more force of attraction towards the valence electron, causing the atomic radius to reduce. So the one which is going to be on the most right hand side, it is going to have the smallest size. So the chlorine is the one which is on the most right side, so it is going to have smallest atomic radius. Then they are saying which element has the most exothermic electron affinity. So first of all, we are going to see that this is magnesium, that belongs from group 2, and it has 12 as its atomic number. And then we have bromine, okay, and then we have sodium and potassium, they belong from group 1. So we are going to see this thing that bromine is going to be the most exothermic. Why? Because bromine is most exothermic. The reason is that they belong from group 7. They belong from group 7, and group 7 elements, they basically, first of all, they are present on the most right hand side. It has the most greatest nuclear charge. So it has the greater nuclear charge. And the other thing is that it is present on the most right side, having the greatest nuclear charge and the smallest atomic radius. So these are the factors that makes it the most exothermic electron affinity. So bromine is going to be the answer. The other reason could be that it belongs from group 7, and group 7 have the most exothermic electron affinity values. Affinity values. So they are saying the next question that various trends can be observed groups and across periods in the periodic table. Which statement about these trends is true? Ionization energy increase going down a group? No, it decreases because of increase in shielding electrons and because of increase in atomic radius. Atomic radius generally decrease across a period. This is absolutely right. So our answer is going to be, why this is right? Because of increase in nuclear charge, there will be decrease in atomic radius across the period. And then electron affinity decreases across a period? No, it increases because it is also dependent on nuclear charge. And electron affinity generally increases down a group? No, it decreases. Why? Because of increase in shielding electrons. Okay, so next question. Now they are saying that successive ionization for an element X are shown in the table above. What is the most likely formula for the ion of X? So if you are going to see ionization energy, then this is getting doubled. But if you can see the ionization energy of second and third, then you are going to see it is basically increasing more than 4 times. More than 4 times. Why is that? The reason behind is that definitely the element X is going to have two electron in its outermost shell, because after that they are withdrawing electron from the inner shell, and when they are withdrawing electron from the inner shell, then because of greater attraction, to nucleus in the core shell, attraction to nucleus, we have to provide more ionization energy. So you can see a sharp ionization energy after second electron. So definitely this atom must need to have two electron in its outermost shell. So when they are removed, then what happens, that this one will be the answer. So definitely it is going to have two electrons in its outermost shell, because after second electron you are withdrawing electron from the inner shell, and inner shell electrons have greater attraction to nucleus. So that is why we are going to see a big jump after second ionization energy. So in the next question they say, which of the following identifies the most probable value for the fourth ionization energy of boron and provides the best justification. So boron is B511, its electronic configuration is going to be 2 3. So that means boron is having 2 electrons in its first shell and 3 electrons in its outermost shell. So if you are talking about the fourth ionization energy, then definitely you have to withdraw fourth electron from the inner shell, from the core electron that are present in the inner shell, and it has greater attraction to nucleus, and the ionization energy would be increased dramatically. So they are saying what gives us the best justification. So that is going to be the C option, because the electron removed during the fourth ionization is a core electron. This is the right explanation for this. Then in the next question, which of the following electron configuration represent the element with the highest electron negativity? So if we are going to see this question, then this one is going to be 1s2 2s2 2p3. It has 7 electrons, so it is going to be nitrogen. Then we have 8 electrons, so it is going to be oxygen. Then we have 10 electrons, so it is going to be which one is S2 is going to be 4, 10, 12, so it's going to be magnesium. And when we see 1s2 2s2 2p6 3s2 3p1, so this one is going to be aluminium, having 13 electrons. So now they are saying elements with the highest electronegativity is going to be electronegativity values. And as we know, the electronegativity value that increase across a period and decrease in groups. So if you move from left to rightwards, then what happens? Electronegativity value increase because of increase in nuclear charge, So what happens, which element is present on the most right hand side? That is going to be oxygen, which has the highest electronegativity value. Then they are saying which of the following arranges the ions in order of increasing atomic radius. They, let's first find out the electrons that they are having. Before finding electrons, we need to see that how many electrons. Okay, first see electrons. So electrons here are, calcium is having 18 electron. Then potassium K positive is also having 18 electron. It is also having 18 electrons. So everyone is having 18 electrons. So now how many like protons they must be having? It is having 20, it is having 19, it is having 17, it is having 16 protons. So if you can see that with the increase in the number of nuclear charge, atomic radius would decrease. So the smallest atomic radius would be of calcium, which is having the greater nuclear charge. So calcium would be having the smallest atomic radius, then and the greater is going to be potassium, then it should be calcium chloride, then it should be sulfide. Okay, so it has the greatest radius. Why? Because of the smallest nuclear charge, and we know nuclear charge is inversely related to atomic radius. So our answer is going to be A.